Hi everyone. Good morning. Okay, your SPM SPM. Okay, for 2023 means last year Form 5. Okay, their SPM start from the 5th of December for Amali Science. Means you all do experiment yourself individual. Okay, then started January 2024. They already have other listening tests. It started on 29 and 30. Sorry, 30, 30, 30, 31. 30, 30. 31 start their menu list already. Okay, then our government plan to start over our New Year, school New Year on 2026. Means what? Means your 2024 SPM every year will move back 3 weeks. Okay? So the real SPM will be on for your bachelor, for 2024 bachelor, will move back 3 weeks earlier. So means if they haven't give the real date yet lah, but means what? Means I think around 10th of January 2025 you will start your SPM already. Okay, means what? Means around November or around I'm not saying March lah. Okay, around here you will start your Amali, the real one. Means what? Means your trials will be at the end of September or maybe 1st of October. Okay, 2025 we don't care first lah. But if we estimate that 1st of October will be your trials meeting. Okay, then now is March, April, May, June, July, August, September. Means by the end of September, okay, we must finish all of our syllabus. And then March only got 2 weeks, April 3 weeks, May holiday, June holiday again, 3 lah, let's say. July, August might be 4, 3, and 3. Don't forget we still got holiday and we still got many things else. And we still got some programs sometimes clash. So actually we just left around 21 weeks on me. Okay, and I tell you, Form 5 physics is a little bit harder than Form 4. Means you need more time to understand it. You need more time than Form 4 to understand the concept. Okay, so not enough time for you. So I must have online class. Okay, and then I will record lah. For those who are not convenient to present now, they should watch video. In school, we really no time to finish it. I just can't tell them. Okay. Okay, it's the problem of our time is shortened. Okay. Okay, so now we start this one first. Okay, my plan now. Chapter 1, I think I will have online class only. In school, I will start in chapter 2. Just my plan. Okay, so now really no time to finish. Okay. The PPT advised us teach those who really need only. Those minor one, no need teach. Okay. But I want to tell you for physics SPM, all chapter, all topics will be asked, either in objective or subjective. And then the prediction for the SPM, last year only 2 questions. The essay question is predicted and is asking, but paper 2 we got 11 questions. Just 2 questions predicted out. Then 9 questions, all distributed evenly. That means all will come up. All maybe come up. So we really must master every topic. That's why no time. Okay? And sometimes the concept is you need time to understand. Okay? So no need waste time. Come, let's start it. Okay. Forces and motion 2 actually is the sambungan for Form 4 chapter 2. Okay, in this chapter, some we already learned, but we learn more detail with the formula. Okay, so now we're going to learn sums of forces, resolution of forces, forces in equilibrium, and elasticity. Okay, this one is about spring. This one last. And then, I think when school reopen, we will directly do this experiment first. This is one of the hot topic to come out in Amali. Okay, so this one, I think I will have online class. And then if you're really not sure, can ask me in school. Okay, I encourage you, you can reprint the drawing one and you redraw. Okay, like sums of forces, we will have 2 forces, we sum up, we add together. So called resolution of forces, or in other words, we say net force. Net force. And resolution of forces means we separate the forces, resolve. Wait. Okay, so forces in equilibrium is net force equals to 0. We have learned last year, but I will explain it again. Alright, so now, when you want to find the net force, you need to draw the free body diagram. Means you need to indicate the direction and magnitude for forces. Okay, what is the meaning of magnitude? Like anyone can tell? Try to think back what is magnitude. A number variable. Okay, then the direction and the magnitude shows that the force is a vector quantity. Okay, what's the meaning of vector quantity? Vector means you need to count direction. This is how I remember. Vector can be an arrow. Arrow shows direction. Yeah. Okay. So now, let's see the arrow. Okay, an arrow, normally we say this is the head, this is the tail. Okay, then most of the time we will put the arrow in the center. Okay, in the center. Means like this is the real arrow, but we put the head at the center lah. Okay. Then before we start, we must know what's the difference between mass and weight. Okay. Okay, the common mistake is Winnie is weighing is weighing is weighing classroom WEIGH is weighing in 50 kg. Okay, now question. 50 kg is mass or weight? Right, please answer. Thank you, Bethany. Thank you, Dylan. The rest? Thank you, Savendra. Yeah. Yeah, answer is mass. Even though they use the word weighing. Actually, weighing here, the meaning is measuring. Measuring. 50 kg. Why we say it's mass? Because kg indicates mass. Kg. So whatever they say in front, we physicists, we look at unit. Okay, unit mass. Okay, then the weight actually is the Newton in N. So actually what is weight? Weight is a force. Okay, mass is the quantity of matter in an object. So we can relate this to Form 1 syllabus. Remember, a solid will have particles arrangement like this. Okay, now, so actually what is particles? Okay, particles means matter. In Form 1, we learn matter has mass and occupied space. See, the particles has mass, occupied space. So we say it's the quantity of matter in an object. But of course, since you learn chemistry, I'm sure you already learned particles actually classified as 3. Number 1, atom. Number 2, molecule. Number 3, ion. Okay? Okay, in chemistry, you must state very clearly for every particles. It's atom, molecule, ion. But in physics, so far, you just say matter or particles, it's okay. Okay, so it means how many particles inside that object, then that's the mass. It's scalar quantity, no need count direction. So the value is constant in everywhere. No matter on Earth or on Moon. Let's say your mass is 50 kg. Earth and Moon always the same. All right. Then what is weight? Well, weight actually is, anyone can tell? The gravitational on the object. Anyone can fill in the blank. The weight is the gravitational what on the object. Thank you, Bethany. Thank you, Savendra. Yeah, it's a must to say force. It's a force. I just highlight. Okay, why I say so? Because actually, when when you was young in primary school and in Form 1 to Form 3, we always mention gravitational pull. Okay, last time, okay, acceptable. Form 1 to Form 3, but our textbook say it's gravitational force. And then SPM schema also only accept gravitational force. So if you still used to gravitational pull, please I mean cancel it, use force. Yeah, we will say force is like pull and push ma. But they want to accept the force. They want to mention the weight is a force. So use gravitational force. And then it is a vector quantity. Gravitational pull or gravitational force always goes down towards the center of the earth. Okay, Newton, then its value varies, or we say changes. The value will be changed, so it changes with gravitational field strength G. Okay. So actually, what is gravitational field strength G? And I believe all of you already know G is 9.81. But do you still remember what's the unit behind? And actually, G got 2 units. Anyone can remember what's the unit? Yeah, number 1 is meter per second per second. Okay, yeah, correct. Oh, no, it's per second per second. It's gravity. So the G here can say is gravitational acceleration. Yes, correct. Okay, why I mention weight? Because SPM 2022 asking this. Okay, asking this. And then 2023 that just passed one didn't mention this, but 2022 mentioned. And many students cannot answer properly. Okay, another unit is called gravitational field strength. Means it is Newton per oh no, Newton per meter. I think it's Newton per meter square. Hey, wait. Okay, let me check back this. Okay, gravitational field strength. Gravitational field strength. Oh, sorry, Newton per kg. Sorry. Per kg. Newton per kg. Means every 1 kg, will experience 9.81 Newton of force on it. Okay, it's actually G. Yeah, both 9.81. But there are two units. One we could say gravitational acceleration. Hi, Sheng Yu. Sheng Yu. Okay, another one is Newton per kg. So let's see our formula. It's over here. Let's see. The last page of our formula. G equals to meter per second or Newton per kg. Okay, so I will always ask back what is weight, alright? In this chapter, weight always exists. Always exists, so I must make sure you know this before we start. It's a prior knowledge lah. Alright, so now resultant force. Most of the time we call it as net force, and because shorter lah. So the resultant force is a single force that represents the vector sum. Sum means, anyone can tell what is the meaning of sum? Yay, total, yeah. Total means you add up lah, you plus lah, add together lah. Two or more forces acting on an object. Then apa itu vector sum? Okay, so I believe you learned in Form 4, Chapter 6, AdMaths. Form 4, AdMaths, Chapter 6. So vector normally like this, plus this, then they become this. Let's say F1, F2, they become F3. Okay, so vector means they have the direction, so you need to count your direction. So resultant force actually is a single force, represent the vector sum of two or more forces. Okay, or another way, sum or minus, plus or minus. Total means plus or minus. Last year, we learned that net force actually is one force minus another. Because last year we learned net. What is net? What is net price? Means after you minus. So actually sum including plus and minus. Right? So now let's see. Situation 1. This is the simple one, just left and right. Left hand side and right hand side. Left and right. Right? So if yeah, sorry, I should put here positive, whatever. Okay, so 50 Newton to the left and 50 Newton to the right. Okay, so the resultant force will be 0 lah, because left goes to right. So no arrow lah. And actually how it works, we can say FA minus FB equals to 0. So 50 minus 50 is 0. Okay, or we will say 50 Newton positive plus this one 50 Newton negative. So plus negative 50 equals to 0. Okay, so for forces, if we write 50 Newton, but negative means goes to opposite direction. So normally we say minus left minus right. Or we just sum out plus negative. That's it. Alright, so now this is okay, so now this one. This is 60 Newton, this is 50 Newton. So we could say FA minus FB equals to negative 10. Means what? Means 50 is positive. Means now you indicate 50 is positive to the left. So negative to the right. So you just minus lah. When they are opposite direction, they can just minus. And negative shows what? Shows negative to the right hand side. Look. So negative here just means the opposite direction to the positive number. Because we fix left hand side is positive. So opposite right hand side will be negative. Okay? So the positive negative here indicates the direction. Okay, so here we'll have more force. So this is your resultant force. Actually, same as the vector mx. The final will be two direct, will be two arrow, the net force. Okay, now if we set to the left hand side is positive, means to the right hand side will be negative. So 60, we can say 60 vector sum. Sum means plus negative 50. So actually is you can directly minus lah. So positive 10 indicates what? Indicates 60 is positive. So goes to the direction of 60. So this side. Okay, so Shen Yu asking, so the resultant force of positive value and negative value is determined through direction. Yes. Yes. Negative means we follow the direction of negative force. Positive means we follow the direction of positive force. So you can simply indicate left, right, positive, negative, up to you. But of course, our mindset already used to number line. 0, 1, 2, 3. -1, -2, -3. So our mindset already used to goes to the right hand side is positive number, goes to the left hand side is negative number. Okay? Most of the time we set like that. But why I show like this, left hand side positive, right hand side negative, just want to let you know you can set anywhere positive as long as your final answer follow the direction of which side you set. But after this, I will always indicate right hand side is positive, left hand side is negative. Okay, like calculate the net force and the direction of the net force. So for example, this one, if they are in same direction, all right, so it will be 10 plus 5, then it will become 15. So why plus? Because both of them in same direction, so you just sum up plus positive 5. You'll get positive 15, means 15 to the right hand side. Okay, if different direction, you got two ways to do it. Normally, we use the bigger force minus the smaller force. So obviously, your net force will be 7. Or we write in this way, net force equals to 10 minus 3 equals to 7. Don't forget Newton. No. Your final answer, no unit. Sorry, no marks. Okay. So far, your your last year, your PAT peperiksaan akhir tahun. I still can mark many students forgot the unit or wrong unit. Okay. So now just want to tell you, positive 7 means follow the direction of positive 10. Okay. So now this one, you can say net force equals to these two in same direction. We sum up 9 plus 17. Sum actually means plus. This is negative, negative 11. But if you don't want, never mind, you just minus. Just minus 11. So you will get 26 minus 11, 15. Direction follow the positive path. So the direction actually is like 15. So can we get back? You think this is correct? Anything wrong here? Yeah, no unit. No unit wrong, right? So now this one. Okay, so normally we set go up positive lah, go down negative lah, normally. Okay, so now we say what net force equals to 5 plus 2 minus 13. So 7 minus 13, 6 Newton, correct? Yeah, normally when I ask this, there's something wrong here. What's wrong? Something wrong. What's wrong here? Yeah, negative. Okay, positive 7 minus 13, negative 6 means your net force will follow the negative sign. Will follow 13 direction. So your net force would be 6 Newton, right? So we can draw like this. Double arrow shows the final. Final means the net. The net means the resultant force. Okay, now F1, F2, F3 are forces with same magnitude. If you are acting on a toy car, which diagram shows the maximum resultant force acting on the toy car? Okay, this question got something wrong. No, actually can say no wrong. Also can say no wrong. Can say no wrong because on a toy car, and then this toy car is at rest. Is at rest. So now there is one force pushing it. This is left hand side, this is right hand side. Or we also can say this is forward, this is backward. Okay, when they say same magnitude and they do not get you anything, you can just give some magnitude, maybe 10. So this is F1 10 Newton, F2 10 Newton, F3 10 Newton. Okay, now let me know what is maximum resultant force. Thank you. Now I have C 2 volts, A 1 volt. Can let me know some more? Maximum resultant means the factor sum. Okay, C. One more person. One more. Tell me one more. Okay, even though it's online class, if you don't have output means you answer my question. It's very blurred. Okay, you will be very blurred, hard to understand. Ah, one more response. Only 4% focusing, is it? Okay, my neighbor, 迎亲叫什么？Married, the bridegroom. They are coming up with the car. Okay, yeah. Okay, so yeah, answer should be C. Okay, because you can see these two would be 20 minus 10, 10 Newton to the right. This one would be F1 plus F3. See direction? So it's 20 minus 10. So it's 10 Newton to the left or backward. Then these three, same direction. Same direction, 1, 2, 3. So it would be 30 Newton to the left. This one would be, see, these two same direction, 20 minus 10. So it will be 10 Newton to the left. So let's compare. It will be like this, like this, like this, like this. So obviously, even though it goes backward, but it's a toy car, doesn't matter. So yeah, maximum resultant force would be C. 30 Newton to the left or go backwards. Don't worry, it's a toy car, not your real car. Switch on my computer. Okay, so resultant force means same direction you add up, even though one front, one back, one front, one back, same direction you add up. Opposite direction you minus. We use more force minus the less force. Alright, so now before we start the calculation for force, okay, we need to identify the name of forces first, okay? And we need to know how to draw a free body diagram. So actually, free body diagram means this one, the arrow, okay, the arrow. So, and it's not a necessity you must start your arrow from the center. You simply draw, but the direction correct, your diagram correct, direction. But of course, if you can draw in this way, it's the best. Okay, now this is the free body diagram. On the apple, there are two forces acting on the apple. Okay, an apple is hanging with a string in the air at rest. Anyone can tell what are the forces? So, what are the two forces acting on the apple? This is a string. This is a string. And this apple. Asian, what are the two forces acting on an apple? Okay, very good. Very good. Thank you, Dylan, Grace, thank you, Ishan. Yay. Okay, let's see. Okay, gravitational force and elastic force. Gravitational force, mass and gravitational acceleration, tension. Okay, yeah, this is a force, very good. Not the answer, but yes, they are force. But be careful, mass is not the force. Mass is not the force. Mass is the quantity of matter we just learned. So mass is not the force. All right, mass is not the force. And some more, gravitational acceleration is not the force too. Is also not equals to force. Understand? Yes, very good. Thank you, Bethany. Yeah, Bethany tell that it's weight. Yes. Actually, what is weight? Actually, weight is gravitational force acting on the mass. So weight actually is a force, yes. Tension is the tension of a wire or something, whatever, a string, a wire. When you pull out, when you pull, yeah, got tension of the string. Yes, tension is a force. Okay, tension is a force. Belum bangun. Actually, not belum bangun. It's uh, the quantity. We haven't identified. We haven't recognized, differentiate them yet. Okay, why I always mention force? Okay, so for example, okay, I just remember one question. I find back the question. Okay, so actually is we only can compare force to force. Okay, gravitational force correct lah. But here got object. So gravitational force act on the mass or the object. So actually it is weight. Weight is more suitable. Okay, so don't worry, we just clarify it out. Next time we won't make this mistake lah. Okay, so tension. So actually the two forces here, one called tension of the spring. So we say tension. Okay, tension of the string. Tension is a force. So remember, tension is a force. Then the apple got gravitational force acting on itself, on the mass. So actually we call it as weight. Weight is a force too, right? So I think, and let's recall back, actually weight equals to what? Weight equals to mass times gravity. Okay. Actually, there's something wrong here. Can you tell me what? If I say gravity, can... Yes, thank you. Yeah, okay, I done correct. Actually, we learned this in Form 3, and sometimes it confuses us. Weight equals to M. Yes? Yes. Yeah, last time in Form 3, let's say we got 50 kg, then our G is 10. But forget about this. Since you are in Form 4, Form 5, you have more matured mindset, and you can you can handle the decimal. Actually, it's 9.81. But as I said here, stop using gravity only. We must say gravitational. Okay, we can say gravitational force. So in this way, since both of them are force, so we could say that it's gravitational field strength. It's gravitational field strength. So means what? Means it would be 50 times 9.81, and we will get the weight is 50 times 9.81. Oh, apple cannot be 50. Apple 50 kg, we cannot eat it. Apple is around 200 grams. 200 grams would be 0.2 kg. So it's 0.2 kg times 9.81. If apple 50 kg, to eat. Okay, so it's 0.2 times 9.81. Answer is 1.962. 1.962 Newton. Weight is Newton, W. W actually got many symbols use W as W. So this W here is weight, both are force. Okay, so now you must remember the name of force. So tension is a force. Weight is a force. We won't say weight force. We won't say tension force. Okay, but itself is a force. Bear in mind. Okay, a book is placed on a table. So this book has weight as the force, and R, this R actually called reaction force. Okay, the full name for this reaction is normal reaction force. Okay, normal reaction force. Okay. Normal reaction force. Okay, R. Okay, then actually, what is it? You can understand it as it is a supporting force. Supporting force from solid. But don't explain in this way. You just can understand in this way. Just understand. Apa itu? Okay, for example, is the surface. Okay, this is the Pizza Hut ocean. And now, let's split. Okay. Then now, what happens if I put a stirrer on this surface? The stirrer will stay, right? The stirrer will stay. See, the stirrer won't fall. Why? Because this is the brochure, this is a surface, solid surface. Okay, then I put a stirrer on it. It won't fall because the weight of this stirrer equals to the reaction force. Okay, so that's why you can see actually the reaction force comes from the surface. But of course lah, if you want to draw in this way also can. As I say, the beginning doesn't matter. But why they start the R from the surface? Because it's a supporting force. Okay, so now what happens if I put a remote control on it? Oh no, this one, okay. This one, oh no. Okay, so now what happened is when I put a remote control, this weight is bigger than the normal reaction. For example, this is 10 Newton, but this one only can support 1 Newton. So this one only can support 1 Newton, but just now, maximum 1 Newton. Just now, this stick is 1 Newton. Okay, so they balance. Since they balance, the stick does not fall. Why the stick does not fall? There is a reaction force to support it. So actually, what is a reaction force? It is a supporting force. Alright, supporting force. But we don't use supporting force, we use reaction force. So reaction force is a force. Weight is a force. Alright, now next, a car is in stationary. Anyone can tell me what is the name of this force acting downwards? Yeah, thank you, Bethany. Weight. Yeah. Hey, the rest leh. Hey, I tell you, if you don't answer the question, when time goes by, you will feel tired and fell asleep. If you don't interact with me, you will feel boring and your brain tells you it's the time to sleep. answer the question really helps you focus and helps your output. Thank you, Wei Sim. Thank you, Aiden. Can I say load instead of weight? Cannot. Okay, because weight rarely have the formula mg. Okay, then load. Yeah, actually load is a force. Load is actually another force, correct? But we fixed already in physics, we say the mass acting under gravitational force called weight. Yeah, fixed already. Yeah, cannot change, cannot. You go any country, also we call it as weight. Okay, now the car is in stationary, then this is Malu Road, Jalan Raya. So Jalan Raya is a solid, so it will give back a reaction force or normal reaction force. Why we call normal? Because normal means 90 degrees from the surface. You can see that? 90 degrees from the surface. So we say normal reaction force. But of course, I remember last time when I'm in government school until matrix, we all use R. But when I go university, my lecturer asked us to use English textbook. Wow. So I still remember it's very thick and very heavy. Yeah, they normally like to use N. Okay, but our country we like to use R. Actually, both also can. Actually, as long as you remember, it's a reaction force. Reaction is a force. Weight is a force. Tension is a force. Now, the car is moving with constant velocity. Means what? Means up here is reaction, down here is weight. Since it's moving forward, so actually now we need to have the force up, down, left, right. Okay, so this one going forward, this is front, okay? Going forward, this is front. Thank you, Kelvin. Yeah, very good. Yes, give your answer. Yeah, here, behind is the frictional force. Or we say friction, FR, okay? Then the weight is, the weight actually, we can say that W. So reaction R, thrust. Very good, we see. Yeah, so actually this is a thrust. Normally we give it F also. We also use F. Why we don't use T? Because T normally for tension. Okay. Then, or if you want to describe it, well, you can say it is engine thrust. Any question? Why nobody asked me what is thrust? I don't think everyone know what is a thrust, but nobody asked me. Not the attitude to study. Is it a breakthrough? Thrust is like a force, that big frictional force, is it? Actually is we have thrust first, then only we have frictional force. When you, okay, frictional force. No, sorry. Not to beat. You want to say okay lah. Actually, frictional force, yeah, exists there. Thrust to against frictional force. Also can, but thrust here in Chinese we say 它是一个冲力，冲往前冲。Okay, so engine thrust means the engine create this thrust force. In forward force, yes, we can say that a thrust is a forward force. But don't use the word forward force. We use thrust force. This is just forward force is an explanation, help us to understand thrust. Must use the word thrust, move forward. So depends on the direction. So for example, here got a bird flying in the air with constant velocity. So same thing lah. This bird go forward to the left hand side. Just now forward is right hand side. Just now the front is right hand side. Now this is left hand side. Yes. So actually this bird also got a thrust force. Got a thrust. Okay, we can just say, normally we just say thrust. Sometimes we add force. So actually thrust is a force. The name of force. Okay, the name of force. Okay, so now continue. Now a car is moving with acceleration. So same thing, here we got frictional force, we got weight, and we got thrust. And we got reaction. Okay, so what's the difference between D and E? We will look at the example later. Okay, now, so far this is solid, all contact with solid. Now, water, candle and clay in the water. Candle floats, clay sink. So what are the forces? Yay, very good. Yeah, both also got buoyant force. Both also got buoyant force. So B stands for buoyant. Okay. But if you say buoyancy, it's different. Yeah, looks like the same, right? But this is an adjective or a noun. Buoyancy meaning means the buoyancy is low, so it is second class. So cannot use the word buoyancy. Yeah, it's a buoyant. Buoyant means it is a force. No need, sorry, no need, sorry. No need, sorry. Yeah, it's very good, Aiden. Very good. You check your understanding here in the class directly. So you save a lot of time, much time to revise, and then you have no chance to get wrong in exam. Understand? That's why I want you all interact with me. Give me your answer so you can check it is wrong or right here, not checking in the exam. When it is exam, you wrong there, then it's too late. Yeah, very good, Aiden. Very good. Keep going there. Is there weight in the diagram? Yes, of course. Very good, Bethany. Yeah, the force always comes in pairs. Means when you got a force going up? Sure, you got a force going down. So it's weight equals to mg. Weight equals to mg. Then even though this clay already touched the surface, okay, still got buoyant force, but buoyant force is lower. Then why it can stop here? Actually, it got one more force, reaction force, because touch the surface already. So we can, so why it stop like this? Because for clay, it's like weight equals to reaction force plus buoyant force. Then for candle, we say weight equals to buoyant force. Okay, that's why it stays here. All right. The name must memorize, bear in mind. Many of your senior wrong the questions because they forgot all of them are false. All right, now an object is floating up to the water surface and an object is sinking down into the water. Okay, as I say, no matter where it starts, look at the direction. Look at the direction. Can you please tell me this one is what? This is weight of buoyant force. Yay, going down is weight. Alright? Yeah, thank you, Shenyu. Thank you, Bethany. Okay. Yeah, going up is buoyant force. Yes, very good. Okay. Okay. Sorry and thank you. I prefer you all say thank you to me. No need say sorry. Understand? Okay. Yes, this is a buoyant force B. Okay. So in exam, if they ask you to label, please label with full words. Unless they tell you, just use simple. Weight is a force, buoyant is a force. Right now, this one is the same thing. Weight is the force and buoyant is the force. Okay, now floating up means going up. We put an arrow beside acceleration. Sinking down, we put an acceleration down. So what happened here is these two not balanced. So since it's going up, what do you think? Which force is bigger than which? A. Weight bigger than buoyant force. B. Buoyant force more than weight. Which one? A or B? Thank you, Grace. Thank you, Sarvendran. Sarvendra. Thank you, Aiden. Yeah, answer is buoyant force bigger than weight. Okay. So what we can do for our formula, net force equals to MA. Net force will be buoyant force minus weight equals to MA, the mass of this object times the acceleration. Okay, so this one, of course, is sinking down. Sinking down means weight bigger than the force. That's right. Weight bigger than buoyant force. All right, now, an athlete is kayaking on a river. So actually, this is SPM 2022. Yeah, 2022. What are the forces? What are the forces acting here? Yeah, correct. Okay, buoyant force. You can start from the water surface or anywhere you like, as long as the arrow is correct. So this is buoyant force. And weight, thrust and friction. Correct? Thrust and friction, okay? Thrust and friction. Okay. The friction in the water, normally we call it as water resistance. Water resistance. Okay, weight. Just now, someone saying weights. And you don't forget the weight here actually got weight for athlete X and the weight for Gaia P. So how is the balance, the equation of the force here? Actually, it will be buoyant force equals to the weight of athlete X plus the weight of Gaia P. Balance means it won't, balance up and down means finally it won't go up, it won't go down, it will maintain there. Understand? So this question in SVM 2022, they are asking why the athlete can float on the river. Why this athlete can float on the river? Means one go up, one fly up, one sink down, just stay there. Okay, many people answer wrong because they forgot here actually got two weights. The weight of the athlete and weight of the Gaia P, right? Gaia P. So these two are, so we say the weight, the sum of weights for athlete and Gaia. Okay, the thrust and water resistance. Of course, if you want to move forward, so the thrust must be more than water resistance. We also say FR, but since it's water, we say water resistance. Friction, normally we describe it for solid. So if we say this, we can say F minus FR, FR equals to MA. But for this, we will say buoyant force minus Wx plus Wp equals to 0. Okay, so when we count the force, horizontal and vertical, we always separate them. We won't count, we won't sum up together because they are 90 degrees. Okay, so we will learn later. Now just memorize, not memorize, identify the force first. Okay, now a free fall feather. So of course the feather got weights. Yeah, very good. Yeah, it's traveling in the air. So actually this is W, this is air resistance. Still using FR, but this name called air resistance. So air resistance is a force, okay? Like this. Water resistance is a force. Even though they don't write air resistance force, and we won't call that. But air resistance is a force. All right, now a bird is flying in the air with constant velocity. So forward thrust lah. So apa ini at the back? Yes, this is also air resistance. It is a force, but it's down. Yes, weight, but it's up. Okay, cannot be reaction force. Reaction force means there is a contact surface. There is solid contact, contacting with some solid. So nothing in the air can be a reaction. Air friction, actually, we say air resistance behind lah. Gravitational force, no. Okay, actually, we call it as a lift. Okay, lift is a force. We can say lift force. Or just say lift in the air. Okay, and sometimes we also can call it as buoyant force. Okay, buoyant force. But most of the time, buoyant force, we use it in water lah. Yeah, in air, we can say lift, we can say buoyant, both also can. Chapter 2, we will learn Archimedes principle. It's about buoyant force. So Archimedes principle is applied in liquid or air. So as long as it is fluid, yeah, we can say buoyant force or a lift force. Most of the time we use the word lift. Okay, now a floating hot air balloon. Okay, a floating hot air balloon. So of course, this one got weight. Floating means stops here. Not going up, not going down, not going forward, not going backwards. Floating. So what is the force here? Yay, very good. Yeah, you can say it is a lift. Most of the time we say lifts right in the air, or you can say it is buoyant. Okay. What is the difference between lift and air resistance? Air resistance is like friction. Like when you're going forward, you will feel the friction to the back. But we don't call it as friction. Friction is when two solid surface they are in contact, friction. But you can feel the wind come towards you and block you. That's called air resistance. Okay, the wind that block you opposite direction to you called air resistance. That's why I see when this one stops there in the air, so no air resistance because not moving now. Okay, air resistance normally It's created when you start to move. It's a force to oppose motion. Okay, so what is a frictional force? We also can say frictional force. And frictional force is a force to oppose motion. Okay, frictional force is a force to oppose motion. So actually air resistance, we also can say air resistance is a force to is a force oppose motion. So water resistance, yes, we also can say water resistance is a force oppose the motion. Water resistance is a force oppose the motion. Yeah, so all of them are force. Force oppose motion. So let's see how many force we have learned. How many force we have learned? Okay, number one. Number one, tension is a force, weight is a force, reaction is a force, friction is a force, thrust is a force. You can describe more detail lah. Engine thrust, the foot thrust, forward. We can say forward thrust. Okay. What else? Buoyant force is a force. Buoyant force. Air resistance is a force. Water resistance is a force. Lift is a force, or we can say buoyant force. Yeah. So we got how many force? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 already. All of them are forces. Okay, so now this one. A rocket is moving up to the outer space. So actually here got two forces. From the rocket itself got weights. And then it's going up, so we got air resistance. Okay. Then this one we can say it is a thrust. Not lift. This one is going in a motion, so it's using engine. It's using engine to have, or we can say thrust lah. Is a thrust. Is a thrust. Okay. And then this thrust also come from, can say engine is a thrust. So it is thrust because it's going. Lift doesn't use energy. Yes, lift doesn't use energy because of the density, less dense or denser. Yeah, this one why we don't use thrust up, because the thrust is going front. Then the lift is to maintain it in the air, to maintain in the air. Lift not powerful enough to carry the rocket go up. One is pulling, pulling. Oh, this one. This one, It is a string, so called tension. Tension. So we use T lah. So already give you T, tension. Tension and weight is correct. This is weight. Oh, be careful, Last time SPM, yes, 6 kg is 60 Newton, but now no more already, You can use weight to get back mass by using weight equals to mg. So 60 equals to m 9.81 and m equals to 6.1162. 6.1162 kg. Not 6 anymore, it's 6.1162. Cannot convert directly, must use formula. And don't forget, we always follow the APMET's decimals. Your APMET's always 4 decimals, right? We follow 4. An object is at rest on an inclined plane. Incline means it's a raised up surface. So actually, no matter your... Okay, so let's say this is your surface. Normal reaction like this. So when you tilt your surface, your normal reaction also tilts because in between them must be always 90 degrees. 90 degrees. Okay, so when you tilt the surface, the normal reaction also tilt. But the problem is the weight always act to the center of Earth. So this is weight lah. This is weight. And this is normal reaction. Okay, normal reaction always 90 degrees to the surface. Understand? So at rest means here got friction. Then what is balancing it? It is, we will learn this after a few topics. Okay, so now this is weight with some angle. So this weight will be separated into 2 parts. So if we follow this, it will be Wx, horizontal weight, and this one will be vertical weight. Apa I need not understand right now, just forget about these 2. Just remember these 3. It's okay. Later. Name first, alright? Name, see, one more. Actress. The rest always the same. Tension. Okay, so here, a trolley is pulling to the right by a load with a constant acceleration. Okay, load. Yes, it is a force. Actually means this is the weight. Alright, load means the weight of the load. Okay, then trolley, normally we use, here got friction. Else. Okay, in between here got tension. Okay, so why the tension in opposite direction? Okay, so here is a string. Yeah, a string, curved one. Then when I pull it up, it becomes straight. Why it becomes straight? Because I got one tension to the left. Sorry. When I pull to my left, there is a tension to the right. When I pull to my right, there is a tension to the left. That's why tension always against each other, right? Tension. Tension exists when you start to pull it. If you don't pull it, no force. Okay, so when you see a trolley, this one called a pulley. When you see a pulley system, pulley 华语叫做滑轮，小学学过的，对不对？滑轮。Anyone can tell me where can you see pulley in the school? Where can you see pulley? I give you a hint. During perhimpunan, no matter in hall or it's in the field. Yeah, the flagpole, yeah, very good. Okay, so when you see the pulley, please straight it up. Okay, we make it horizontal. So we transfer our force here. We make it straight. This is friction. This is weight. Okay, then in between we got tension. Okay, it's a must. When you see pulley, this is horizontal. We pull it up. Okay, we make it in a straight line. Now this one, when you see a pulley, okay, we straighten it up. Now, okay, so pulls a mass of 3 kg by using a pulley means going up here. So don't forget to add acceleration going where. So going here, and we make this part as downward part. Okay, so yeah, this is a pull force. Yeah, this is a pull force. Then since this going up, so if we make it straight line, you can see that this one will move up, become straight line. This one will move up, become straight. So we will have 3 kg here. What is the force acting on a 3 kg block? Gravitational force act on an object. What is the force? What is the name of the force? Yeah, gravitational force act on that object. We call it as weight. Some of you might, what? Yeah, it's weight we always mention. Yeah, so now the weight we pull up lah. So we pull up, weight become 3 kg. Weight for 3 kg. Okay, so we just make it straight. Yeah. New technique, must learn. Okay, so must draw this easier for you to calculate the rest. Now, this one. An object 3 kg is pulling up when object 5 kg is released. So when they are same height, then when you release both, of course, the 5 kg will go down. So actually, what is the force acting by the 5 kg load here? Very good. So weight for 5 kg. And here is the weight for 3 kg. You can name it as W1, W2, but I normally like to give name same as the object. So going down here, because 5 kg is heavier than 3 kg. So I will put here weight of 5 kg and then acceleration going down. So this is 5 kg and this is 3 kg. So may I know what should I write here? What is the force should I write here? I bend it up. I bend this up like this. For example, I got two sides. Okay, this is 3 kg, this is 5 kg. Okay, so I bend it up. Can understand that? I not bend. I make it straight. I pull the 3 kg up. 3 kg, 5 kg. Now I pull the 3 kg up. No, so actually it is the weight for 3 kg. Yeah, weight is a force. Weight is a force. I just straighten it up, you know. I just straighten it up. So 3 kg here. W 3 kg is opposite direction for 5 kg. New skill, but you must learn. Yeah, we're going to calculate this. Yes. So if you don't know how to make it straight, it's hard for you to do lah. So we make it straight lah. So pulley, actually with one string and then with pulley, the force you can apply the force in any direction. It doesn't matter. Okay. So actually here also repeat only frictional force, tension, the weight, pulling force. Why I say pulling force? Because there is a person pulling, really pulling. But these two, no pulling force because the weight for 5 kg is pulling the force by 3 kg. So the 3 kg is like against it lah, like resistance lah, right? So actually they are against to each other. They're against to each other. So these two are the forces. Okay, happy? I give you 2 minutes. Recognize back all of the force. So actually we got 10 forces only. 10 forces. But when we apply in different situation, it's confusing. I'll call your name and answer my question, alright? It's a quiz. Okay. Ha, 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 ha. Okay, so there is a bird flying here, and then there are 4 forces. Okay, like Bethany, tell me what is this on mic? Fast, 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 on mic faster. On mic faster, fast, fast, fast.
Trust.
Okay, trust. Trust.
Air resistance.
Yeah, air resistance. This one?
Lift.
Yeah.
And weight.
Yes, very good. Thank you very much. Okay, now this is C. There is a submarine. There is a submarine. Submarine. Okay, submarine. Going forward. This one move in constant depth. Constant depth means not moving up, not moving down, but only move forward. What are the forces here? Like I didn't. What is the force here? On my fast.
This one is trust.
Yes. This one is
Water resistance.
water resistance. This one is
This one is buoyant force.
this one.
Weight.
Very good. Thank you. Okay, now I have what? I have. This is the wall. Like this, the wall. And I want to hang a plant like this. Hang a plant like this. Plant. Hang a plant. These two are string. These two are string. What are the forces acting here? What are the forces acting here? Like Alicia can. Alicia can. Alicia. Alicia. Can Alicia try? Alicia. Alicia. Can or cannot? Just tell me. Okay, Alicia not around. Like Xingyi, on mic, like Xingyi. So what are the 3 forces acting here?
Tension.
Tension 1, tension 2, one more.
Weight.
Yeah, the weight's going down. Yeah, very good. Okay, then this is a car. Okay, this is a trolley. This is a trolley. Trolley moving forward. So there is a force backward. Up got 1 force, down got 1 force. Like Grace can tell me what as this is forward. This is in front. Here is
Trust.
yes, this is a truss. Then this is
Friction.
Friction. This is. Or tell me the symbol. This is table. It's a solid. So what is the supporting force? Okay,
Normal reaction.
yes, correct. So what is this?
Weight.
Yeah, very good. Okay. So now, okay, thank you very much. So now, calculate the net force by using net force equals to MA. Okay, so for example, given that a book with mass 1.5 kg is placed at rest on the table, at rest means initial velocity 0, final velocity 0, acceleration 0. So calculate the normal reaction R from the table. So R actually is normal reaction. It is a force, then this is the weight. Okay. So now how we will get information first. M equals to 1.5 kg. The weight is mg, so weight is 1.5 times 9.81. So what is R? R is a normal reaction. Normal reaction. A is acceleration. So since at rest, so acceleration 0, so we always use net force equals to ma. So the force we always put on left hand side, m times a we always put on right hand side. Okay, so left hand side net force means there are two forces minus each other. So for this case, we can use R minus W. So W we already got 1.5 times 9.81. 1.5 times 9.81 equals to 14.7. 14.715. 14.715. Okay, so A is 0. Okay, M times A 0 at rest. Then we move this minus 14.715 to right hand side. So just now we get 0, 0 plus 7, 14.715. So we say net force equals to MA. So we say R minus weight equals to MA, R equals to MA plus W. So MA just now we already know 0, so I'll say 14.715 R. Normal reaction with 14.715. Can I get marked? Yeah, no unit wrong. So unless you write 14.715, we look at R. R is normal reaction force. So force is Newton. Okay, we always check on our left hand side. Okay, now again, everything here, use this formula only. But this formula is confusing because people forgot to minus. Okay, one force minus another. Okay, one force minus another. Okay, so now given that the frictional force is 500 Newton, we write here, then we write in our info. Mass of the trailer. So this is the trailer. So the mass is 2000 kg. This is weight lah. So weight equals to 2000 kg times 9.81. Okay, mass and weight different. Then acceleration of the truck is 20 meters per second. So we write acceleration equals to 20 meter per second per second. Okay, then calculate the pulling force of the trailer. Okay, so this is truck. This is trailer. As long as you see force, mass, force and mass, then always use, and then got acceleration, we always use net force equals ma. Okay, so since they link together, so so acceleration for truck and trailer will be the same lah. Okay, so now it will be pulling force minus the fractional force equals to ma. Pull is a force. Okay, so we always put force on the left hand side. All of the force we want plus minus on the left hand side. Then right hand side we always put mass times acceleration, right? So pull is a force. We want pull minus friction. We already know 500. Since they just one trailer, so we just put trailer 200, 2000. Acceleration 20, substitute. So in this case, we just focus on the horizontal force. Can you see that? They never ask for normal reaction and we never ask. So we just focus on horizontal enough. So then we substitute 40,000 plus 500. So we'll get 40500. What's the unit, huh? What's the unit? Newton, yes, because pull is a force. Yeah. Okay, so then we can see all of this. So your homework, you can try up to page 6. Yeah, so actually how to solve it, always use one formula only. Net force equals to ma. Net force equals to ma. So an apple is hanging in the air at rest. Be careful. At rest means initial velocity 0, final velocity 0, acceleration 0. So means here A0, we can make it as 0. Net force is what? Since here only got up and down, two forces only. One is tension, one is weight. Okay, so the mass of an apple is 0.3 kg. Even though whatever times 0, 0, so we no need substitute. Calculate the tension of the string. So since they are equal, so we can say up minus down, tension minus weight equals 0. So tension actually equals to weight of an apple. So weight equals to mg. 0.3 times 0.3 times 10. Is it correct? Is it correct? Yeah, it's 9.81, correct? So it's 9.81. Then your answer in Newton, correct? Okay, this one is for 0, but this one you can see falling down. Acceleration. This one please change to meter per second per second. Okay, so going down with acceleration 1 meter per second per second. Okay, so this one also the same thing. Net force equals to ma. But the problem is here we got acceleration. We must substitute lah. So m 0.02, a is 1. Net force is, this is air resistance. This is weight. So now which one minus which one? We look at A. If A going down, means this side will be bigger. We always check that is there any acceleration? No acceleration, up minus down then. But this one, acceleration going down, falling. So we always use weight minus Fr. We follow the direction of acceleration, then that force always bigger than the opposite force. Okay, so all just use net force equals to ma, one force minus n naught. Okay, so that's all for today lah. So if you don't have any questions to ask, you can leave lah. Okay, thank you everyone. Bye. If you want to ask question, you can stay lah. Say bye before you go. Okay, bye everyone. Bye. Bye bye. Welcome. Bye. Welcome. Bye. Bye. Okay, Sapindra, any question to ask? No. Okay, bye everyone.